Okay, we're recording. So, Renee, I hope you feel better. And who else? AP Bio field trip? No, but why is that whole table gone? AP Bio. So, Christian and Gabe, I hope you're enjoying the animals. Unknown. So, anyway, number one looked like this. And we were given that the height f of x equaled, what was it, 20x squared. Thank you, Kylie. And this one, most of you chose the shell method, and that was a good choice. If you did the washer method, it was long, long, and long. So a lot of you have asked me, when is it better to use the shell? When is it better to use the washer? You just have to look at them, and this one definitely was a shell method, was way better. So we know the height was 20x squared, and circumference, of course, is 2 pi r. And then we have to say to myself, what's the radius? R equals, and this was a biggie, 2 minus x. We have to say 2 minus x for this radius, and that's key because the thing we're rotating it about is the line y equals x, or y equals 2 rather, sorry, y equals 2. Okay, questions on that? That was the biggest single place where people had issues, was in identifying the radius. Okay, so then we say the volume equals the integral from 0 to 2 of 2 pi r. Instead of r, we can put 2 minus x times the height, 20x squared dx. And again, because we identified this as a vertical rectangle like this, we know it's dx, then all of this has to be in terms of x. And that's really crucial. Questions so far? The biggest mistake here, as I said, was people put the wrong radius. Some of you just put x as a radius. Some of you left it off. You've got to account for that radius because it's 2 pi r times the height. Okay, and I'm going to even put that in there just as a reminder. So that's diameter, or I'm sorry, radius, not diameter. 2 pi r circumference times height. Okay? And at that point, you have a shell. And we just put them all together, integral sign, summing them. And then item next, and if you have questions, please stop me. Item next would be move the 2 pi outside the integral sign from 0 to 2. We can distribute the 20x squared across here, which would seem a prudent move at this point. And we get 40x squared minus 20x cubed dx. Okay? Questions so far? Is that part all right? Okay, we're good. If you want to at this point, you can factor out 20. You don't have to, you can. But if you want to, then you can make that, a 40x out there. It's totally up to you. You can say that that's 40 pi times the integral from 0 to 2 of 2x squared minus x cubed dx. Makes it fairly simple. And just to save time then, I'm going to skip the next couple steps. And you should get, well, maybe I should do one more, but it's pretty straightforward. V equals 40 pi times x to the third, and it'd be 2 times 1/3 x to the third minus 1/4 x to the fourth, evaluated from 0 to 2. Okay, and then I'm going to skip a few steps, and your final answer should have been 160 pi over 3 units cubed. Questions on that? Questions on that? Will, is that all right? Okay. Please ask questions if you have them. Okay, item next. How far are we into this? Oh, we're doing great. 5 minutes in. All right, now, number 2 was a line y equals x to the line y equals 2, and then it was rotated about the line y equals 3, which this is a washer. This is a washer problem. It has a hole in it. Okay. Once again, was that a question, Zach? Great question, because we've got to write this thing in terms of x because this is dx. That's a great question. And which can work if you do it right. But if you do it like that, it's a shell. And I think you did it as a circular area. Okay? Because keep in mind, if you do this in terms of dy, it's going to be a shell then, which is okay and totally works, but then you got to go 2 pi r. And I think you went pi r squared. Right. Well, there is that too. Yeah, just a little. But in answer to your question, generally, yes, that will work. Most people went this route. It's more straightforward. Okay, good question. Now, so in this case, if you're doing a washer method, which most of you did, then you've got to say, okay, there's 2 radii. Let's say r for the big one equals 3 minus x. You had to have that. Because remember, right here is 3. And you can think of this as 3 minus y, right? But in this case, what's y equal to? We can say 3 minus y, which is true. There's some y value here. But it's equal to x, so we're covered. So we can say that that's 3 minus x. And then the little r equals just what? 3 minus 2. So a little r equals 1. And so the radius of the hole in your washer is how big, Santiago? Uno. So yeah. So we can do that. So now I think we're ready to set this up. The area of our washer is going to equal pi r squared, big R, minus pi r squared, little r. So I think we're ready then. We can say that our volume is going to equal an integral from 0 to 2. Here was the number 1 mistake. So pay attention even if you're not. Here was the number 1 mistake. People said 0 to 3. But it's 0 to 2 because it's in terms of x. And x goes from 0 to 2. A lot of people put 0 to 3 thinking it was in terms of y, but we wrote it, most of you anyway, wrote it in terms of x. So the limits of integration have to be in terms of x as well. Cannot stress that enough. Milo, is that okay? Okay, limits of integration have to be in terms of x. All right, so hang in there. We're doing okay. So you have the volume equals pi times 3 minus x squared, that's big radius, minus pi times 1 squared, that's a little radius. So then we could think of this as 0 to 2 of pi factored out of this whole thing. And then 3 minus x squared, that's going to be 9 minus 6x plus x squared minus 1. And think of like factoring pi from both terms, which makes it nice because then we can say v equals pi, move it outside the integral sign, from 0 to 2 of 9 minus 6x plus x squared minus 1. That gives us v equals, and right here, some of you mixed up your signs and said it was plus 1, and that made you lose a point. So now we have 8 minus 6x plus x squared. And then we get the volume equals pi times 8x, thank you, minus 3x squared plus 1/3 x. And that's from 0 to 2. Okay, questions? And most of you got it, but like if you picked the wrong radius, that kind of boogered you up. I usually, if you did everything else right but picked the wrong radius, I just put 1 off. I dinged you 1 point for that. And I think all of you can finish that one out, and that equals 20 thirds pi units cubed. 20 thirds. If you did it from 0 to 3, not mentioning names, Kylie, then this would come out as 6 pi units cubed. Somebody else did too. Don't feel bad. There was one other person that did that. Anyway, but that was an interesting one. It was interesting to see how it affected it, because essentially, I'd have to think about it, but I think essentially you were subtracting off. I don't know. That seems too big. I don't know. I don't know. But anyway, questions on number 2? Okay, we might be able to get one more in. All right, number 3 was a cool problem. I like this. Very cool problem. And I did that on purpose. Brett came up all mad at me like, you didn't give us an equation. Well, anyway, if you came up with anything even close to this, I gave you credit. Like a few people had not exactly the right equation, but I got to tell you, pat yourselves on the back. Pretty much everybody came up with y equals 2 root x, or y equals square root of 4x. And that was really nice, because I didn't want you all to lose those skills. I didn't ding you. Like one person had the wrong equation but did everything else right. I gave that person on full credit. So I didn't really ding you if you had the wrong equation, if it was somewhere plausible. Okay? So that was cool. I thought that was really neat. And so now here, Zach, this is exactly what we were talking about before. This one is in terms of dx. So we've got to write everything in terms of x, okay? And the problem is we're given y equals 2 times x to the, or 1/2, or square root of x. I shouldn't do 1/2 yet. Square root of x. So we've got to then use that factor. Okay, so now we've got the volume then is going to equal, and this is a shell, just ignore those homies. Of 2 pi x, because in this case, and this is a point we really got to talk about, x is somewhere in here, but we're rotating it about what point or what axis? we're rotating it about the y-axis. So instead of saying 2 minus x or 4 minus x, which a lot of people tried, it's not 4 minus x at all. It's just x because we're rotating it about the y-axis. So this is 2 pi x times times 2x to the 1/2. Now, real important point right here. You can make your life easier by going 0 to 4 of, and you can move 2 pi out. That's fine. But remember, this is x to the 2/2 times 2x to the 1/2. Very, very, very important point that a lot of people lost. So this is v equals 2 pi 0 to 4 2x to the 3/2. Orion, I think you did not make that step and it made things more complicated. Okay? As I recall. So 2x to the 3/2 dx. And from there it's pretty straightforward. And you get 256 pi over 5. I'm going to keep recording maybe on this. Units cubed. What about them? Oh, I'll have them by 2 o'clock. Grades will be posted. Thank you, Zach. I'm going to pause this briefly. Right, you should. So now we're moving on to number 4 from the quiz. Quiz over sections 7.2 and 7.3. Number 4 allowed you to do the problem as either a disk or a shell, and most people chose the shell. Now notice that the shell is parallel to the line that you're rotating the volume about, whereas if I had chosen a disk, which I could have, it would be perpendicular to that, and that does wind up making a little difference. The nice thing about the shell is if it's expressed as in terms of x, then when we do the width of our little rectangle or the width of our shell as a dx, then we can leave everything in terms of x. So then, as you recall, our function here is y equals, what was it, 2x cubed. So then that's the height of our shell, 2x cubed. The width is dx. And then we have to deal with the radius, which is a little bit tricky because we're rotating it about this green line, x equals 7. And our line is limited here at x equals 2. So this will look kind of like a volcano with the inside blown out, kind of like Crater Lake. So that's the deal. And we need radii then. As with all shells, you're going to have, well, not all, but most, you're going to have a big radius, which in this case will be 7 minus x. And so then we have to think about how to express this whole thing. This volume then will equal the integral from 0 to 2. I'm talking in terms of x. My limits, if I'm dx, which I am, then my limits of integration go from 0 to 2. And then I have 2 pi r. I guess I should stay black. 2 pi times my radius, 7 minus x. times the height, which was 2x cubed dx. And that will give me all of those shells summed together with a giant hole in the middle because it's 7 minus x. Pretty cool. So now we can go, the volume equals, we can pull the 2 pi out front, 0 to 2. We can distribute 2x like this, probably make it a bit simpler. I think that's a good move. 14x cubed minus 2x to the 4th dx. If you wanted to, we can pull out another 2 times 7 and 2 times 1. So we can say the volume equals then 4 pi integral from 0 to 2 of 7x cubed minus x to the 4th. That's pretty clean. Then we get the volume equals 4 pi times, well, it'll be x to the 4th. It'll be 1/4 times x to the 4th. Don't forget our 7 coefficient. Minus, it'll be x to the 5th. It'll be 1/5 x to the 5th. Evaluated from 0 to 2. Okay, so far so good. And then you can blast that out, I'm sure. I don't have to go through those details. That's the setup. And then you will get 432 pi over 5 units cubed when you do that. So that's the deal. And I hope that this vodcast was enjoyable for you all. I'm a little tired, so it's time to head home. And thanks for watching.